So far, we've learned two algorithms that will fit a line through a set of points. One is using any of the tricks, namely the absolute and the square trick, and the other one is minimizing any of the error functions, namely the mean absolute error and the mean squared error. The interesting thing is that these two are actually the exact same thing. What I'm saying is that when we minimize the mean absolute error, we're using a gradient descent step, and that gradient descent step is the exact same thing as the absolute trick. Likewise, when we minimize the square error, the gradient descent step is the exact same thing as the square trick. So let's see why. Let's start with the mean squared error. Here's our point with coordinates x, y, and here's our line with equation y hat equals w1 times x plus w2. So y hat is our prediction, and the line predicts the y coordinate of this point. That prediction gives us a point of the line that matches the x coordinate of our point x, y, so it's the point x, y hat. Now the error for this point is 1/2 times y minus y hat squared. And the mean squared error for this set of points is the average of all these errors. But since average is a linear function, then whatever we do here applies to the entire error. Now we know that the gradient descent step uses these two derivatives, namely the derivative with respect to the slope w1 and the derivative with respect to the y-intercept w2. If we calculate these derivatives, and you can see the calculation in detail in the instructor notes, we get negative times y minus y hat times x for the one with respect to the slope, and negative times y minus y hat for the one with respect to the y-intercept w2. And notice that the length of this red segment is precisely y minus y hat. And the length of this green segment is precisely x. And if you remember correctly, the square trick told us that we have to upgrade the slope by adding y minus y hat times x times the learning rate alpha, and upgrade the y-intercept by adding y minus y hat times the learning rate alpha. But that is precisely what this gradient descent step is doing. If you like, feel free to pause this video or actually write it down in a little piece of paper to verify that it's the exact same calculation. So this is why the gradient descent step utilized when we minimize the mean squared error is the same as the square trick. We can do the same thing with the absolute trick. The procedure is very similar, except we have to be careful about the sign. This is our error, the absolute value of y minus y hat. And the derivatives of the error with respect to w1 and w2 are plus or minus x and plus or minus 1 based on if the point is on top or underneath the line. Since this distance is x, then you can also check that this is precisely what the gradient descent step does when we minimize the mean absolute error. So that's it. That's why minimizing these errors with gradient descent is the exact same thing that using the absolute and the square tricks.